Hello students, today I will take the question number 31 to 35 in NEET 2016. So question number 31 to 35. Now question number 31. Given the value of river constant, value of river constant is 10 raised to the power 7 meter inverse. The wave number of light last line of Balmer series in hydrogen spectrum will be number 1 2.5 into 10 raised to the power 7 meter inverse. Second option 0.025 into 10 raised to the power 4 meter inverse. Third option 0.5 into 10 raised to the power 7 meter inverse. And now fourth option 0.25 into 10 raised to the power 7 meter inverse. This is the given question. Here you are given the Balmer series of hydrogen spectrum. So first we apply the formula for its wavelength. For Balmer series, nu bar, the wave number nu bar equal to 1 upon lambda, and this is equal to r into 1 upon 4 minus 1 upon n2 square. So for last line n2 is equal to infinity. This is equal to r into 1 by 4 minus 1 upon n2. For last line n2 equal to infinity. So what we have? This is equal to r by 4. This is equal to nu bar, the wave number. So this is 0.25 into the value of r. Value of r is given to be so much, 10 raised to the power 7 meter minus 1. This is the value of nu bar. So our right answer is fourth one. Answer fourth. So this is what the wave number of the last line of the hydrogen Balmer series in the hydrogen spectrum. Now question number 32. if the velocity of a particle is V equal to, this is given to be over AT plus BT square, AT plus BT square, where A and B are constants, where A and B are constants. Then distance traveled, by it between 1 second and 2 seconds. Now the solution, the answers. The options are A upon 2 plus B upon 3, and second option is 3A upon 2 plus B, and third option is 3A plus 7B, and fourth is 3 by 2A plus 7 by 3A, 7 by 3B. This is the given question. Now the solution. You are given the velocity and you have to find the distance traveled by the particle between 1 to 2 seconds. So V equal to AT plus BT square, and this is now your ds upon dt equal to AT plus BT square. So this ds equal to AT plus BT square into dt, and you have to find the distance between 1 to 2 seconds. So S equal to integration 1 to 2. This is now your AT plus BT square into dt. So now we indicate to this one. So this is your AT square upon 2 plus BT cube upon 3, limits 1 to 2. Now put the value of t, 2 and this 1. So what will we get? That this is equal to a by 2, this is now your 2 square minus 1 square, plus this is now your b by 3, this is now 2 cube minus 1 cube. So here we will get, after solution, this S equal to, this is now your 4 minus 1, so this is now 3, so 3 by 2A plus, this is now 8 minus 1, so this is now 7, 7/3b. 7/3b. This is the answer to this question. So our right option is fourth one. This is now right answer. Answer is 4. So this is just the direct application of the velocity, where we have to find the distance with the given expression by integrating the velocity expression. Now question number 33. Angle the angle of incidence of a ray of light at refracting surface of a prism is 45 degree. The angle of prism is 60 degree. Angle of prism is 60 degree. If the ray suffers, minimum deviation through the prism the angle of minimum deviation of minimum deviation and refractive index of the material of prism respectively are. Now first option is 30 degree, 1/√2. Second option 45 degree and 1/√2. Third option 30 degree and √2. And fourth option 45 degree and √2. These are the given options. So now solution to this question. You are given the prism, the angle of incidence here, this is now 45 degree, I equal to 45 degree. The angle of prism A equal to 60 degree. This is now A. Minimum deviation through the prism, then we have to find What? First you find the delta M and what is the value of mu, the refractive index of the material of the prism. So just we have this angle of refraction, angle of reflection, R equal to A by 2. So this is your 30 degree. Therefore, mu equal to sin I upon, using the Snell's law. I is given to be your 45 degree and this is given to be 30 degree. So we will put it here, mu equal to sin 45 degree and this is sin 30 degree. So we get from here this mu equal to sin 45 degree, so this is now 1 upon root 2. Sin 30, this is now your 1 by 2. So this will come out to be your root 2. So mu is root 2. Now then you have to find the delta M. And we know that the relation between I and delta M, I equal to A plus delta M upon 2. This we know. So this I is equal to your 45 degree, A is 60 degree plus delta M upon 2. This is now 90 degree. So this delta M will come out to be your 30 degree. It means that delta M is 30 degree, this is now so much, and this mu is equal to root 2. So right option is third. So our answer to this question is third. So this is the application of the formula for the refraction of light through the prism. So if you know the relation between angle of incidence and angle of refraction and angle of minimum deviation, then you can calculate it easily. Now question number 34. The molecules of given mass of given mass of a gas have RMS velocity of 200 meter per second at 27 degrees Celsius. And one into 10 raised to power 5 Newton per meter square. Pressure. When temperature and pressure of the gas and pressure of the gas are respectively 127 degrees Celsius and 0.05 into 10 raised to the power 5 Newton per meter square. The RMS velocity of its molecule velocity of its molecules in meter per second. Meter per second is now the options. First option is 100/3. Second is 100√3√2, and third is 400√3. Fifth is 100√2/3. Now the solution. You are given the temperature and pressure of the gas. Now we know that CRMS equal to square root of 3RT/m. So clearly CRMS is proportional to square root of T, the temperature. If we consider the volume, then we have to use the PV. So there we have to find this, since the mass is not given, that from there we can also find to this one. So this is now your C1 RMS upon C2 RMS equal to square root T1 upon T2. So what we have, C1 RMS, this is given to be so much, 200. This is now your C2 RMS equal to square root T1 27. So this is now your 300. This we have to convert in Kelvin upon. This is now then given a 127. So this is now 400. So this will cancel. So now you can have this is now square root this 2. This is multiplied by this one, so it's 400. So C2 RMS is equal to 400 upon root 3. This is the right answer. So now third, we have the answer. Third. This is now right. This is a direct application of the RMS value of the velocity of the gas. Now then question number 35. An air column closed at one end and open at other resonates with a tuning fork. With a tuning fork. When the smallest depth smallest length of column is 50 centimeter. The next larger length, larger length of column resonating with same tuning fork. Same tuning fork. Tuning fork is, now your options. First is 200 centimeter. Second is your 66.7 centimeter. And third is 100 centimeter. And fourth is 150 centimeter. This is given here. Now solution. This we have the so much close that one end, and this is now first length L1, and then this is now your L2. So you can see that this L1 is equal to, this is now resonant length. So L1 is equal to, this is lambda by 4, because this is your node and this is now antinode. And similarly this L2 is equal to 3 lambda by 4. So clearly this L2 is equal to 3L1, and this is now 3 into 50. So this L2 equal to 150 centimeter. It means that the next larger length of resonating column will be 150 centimeter. So our answer is what? The fourth one. Answer. Fourth. And always remember, when we are given the ear column which is closed at one end, then there are the odd lengths. This is now you can see this is how much? This is lambda by 4, 3 lambda by 4, then next 5 lambda by 4, then next 7 lambda by 4. So if you are given one of the length, you can find the second one. So this is the answer to your question number 35. So as you have seen that the questions are not so much typical, but if you have the knowledge of understanding and the application, and then you can do this. So like, share, subscribe the video, Thank you very much.